All systems function the same. This axiom of truth does not just allow us to connect seemingly unrelated concepts, rather, it can also be applied within disciplines to provide increased depth of understanding. If we look to modern physics, we find the same mistake occurs over and over without thought or consideration. There are systems known as atoms, which are all generally alike. When we say atom, we are talking about a very specific group of particles. Beyond that, there are smaller and larger particles, each of which we separate into their own subset, which are differentiated by how we see them in various ways. There are larger systems, planets and moons, and smaller, such as photons and electrons. These have their own specific characteristics that we observe that then leads to their categorization. Then there are even larger objects, stars. We see differences between each of these from the systems that we call planets and moons, and the classifications of smaller particles such as atoms, that we then use these differences as a basis to separate them into their own group. Beyond that are black holes in a class of their own. On and on we go, focusing on the differences between systems to separate them. However, this approach is inherently extremely complex because it results in our interpretation that each one operates under its own mechanics that are dissimilar to the others. What this suggests is that in order to understand everything about how we see the universe, we have to individually learn about each classified system. Such an approach does not allow for us to look at the mechanics of an atom or a planet to better understand a black hole, for example. This intrinsically carries with it an unspoken assumption that all of these systems function differently. In other words, this interpretation implies that there is no such thing as universality. Atoms are atoms, but they are dissimilar from planets or stars, which are dissimilar from one another, and so on. If we look at this from another angle, what we see is revealing. It is important to note that the universe itself does not have dividing lines that differentiate between which systems are which. We impose these dividing lines ourselves with our interpretations of what we see. Let us suppose that instead of focusing on the differences between systems to separate them, we attempt to focus on the similarities between systems to unite them. If such an approach demonstrated results, then it would support universality by suggesting that all systems share the same mechanics. This would then make it much simpler to understand how anything functions by grasping first how everything functions. So we can look for similarities between systems that are considered to be separate and distinct to determine if they have the same underlying mechanics governing them. Certainly, stars and black holes are not the same mechanically, right? So this must be false. However, if we jump to this conclusion, then we will miss the connections that strongly suggest otherwise. If we look at galaxies, we can see various characteristics that they tend to share. For instance, they all have an object known as a black hole at the center. A common trait for a galaxy to have is that it has a disk surrounding it, where that disk is frequently shaped into spiral arms. When we look at a star, it is not the center of a galaxy, but rather is the center of a solar system where objects orbit around it in a disk structure. However, as we are looking for similarities, we can distinctly see one here. Black holes are the central structure around which smaller mass objects orbit in a disk structure, and so are stars. It is important to note that the mass of a star and a black hole are not the same, and so while the way that we see them exhibit the same mechanics will be differing, the mechanics will remain identical in nature. We are specifically looking for the similarities amongst systems that we see differently to connect them together in understanding, rather than looking for reasons to separate them. Using our solar system as an example, we see it comprises planets near the sun with belts known as the asteroid belt and the Kuiper belt. As the sun rotates, its electromagnetic field produces a spiraling current sheet known as the heliospheric current sheet. This structure is identical in shape to the spiraling of a spiral galaxy, providing another important similarity. What this means is that if these systems do function the same, then the spiral shape of a galaxy is specifically produced by the rotation and the electromagnetic field of the central object, in other words, of its central black hole. That may sound obvious. However, this is an important distinction because current scientific theories have no reference to the rotation of the black hole itself as the underlying cause for the spiral arms. Indeed, it is a common theme when it comes to black holes to interpret observations involving them as not actually being caused by the black hole itself. For instance, the entire concept of a black hole is generally that there is an object so high in mass that it functions completely differently than a star. Thus, this analysis would appear as if it is doomed to failure given the extreme example of black holes. However, it is important to understand the history of black holes. The first object observed as a black hole is known as Cygnus X1, seen in 1971. Prior to its discovery, the concept of an infinitely dense object that was so massive that even light could not escape its gravity existed theoretically as early as 1916, as proposed by Einstein. In 1967, the term black hole was coined by John Wheeler. By the time we had seen the first object we call a black hole, we had already developed extensive theoretical explanation for how it functioned. Then we discovered an object whose existence was clear based on its gravitational influence on its surroundings. This object was later concluded to be the first black hole ever discovered, Cygnus X1. When we look at it in the visible light spectrum, all we see is its influence on its surroundings. As a result of analysis, we could tell an object existed that was extremely massive, but that we could not see. Thus, we concluded it to function according to the theoretical models that were already in place to describe it. However, this made us blind to the obvious. Black holes are more massive than stars. If we look at the solar spectrum of the sun, it emits light largely in the visible light spectrum and near spectrums. The Earth and other planetary bodies also emit light. Instead of emitting in the visible light spectrum, they emit in the infrared spectrum. From a basic standpoint, the main difference between the Earth and the Sun is that the Sun is more massive. As a result, it emits higher energy radiation than the Earth, but the Earth still emits. If we extend this pattern out further, then what happens when an object is much more massive than the Sun? Then its emissions are higher energy radiation than the Sun. Therefore, there comes a point where an object is higher in mass that it no longer emits in the visible light spectrum at all, but rather in the X-ray spectrum. As a result, we would not see it in the visible light spectrum, but would only see its gravitational influence on its surroundings. If we look at Cygnus X1 in the X-ray spectrum, we see a completely different picture. Current scientific theory concludes that these X-ray emissions come from the surroundings of Cygnus X1 rather than the object itself. It is as if we have not even considered that it might be the object itself emitting in the X-ray spectrum rather than visible light spectrum, because we are so stuck on theoretical models that we completely miss what is obvious. A black hole is a star just like any other star, but it emits in the X-ray spectrum due to its higher mass. What this means is that solar systems and galaxies are mechanically the same. In this way, we are able to use the similarities between systems to unify them. It is important to note that we are observing these structures using the systems that we call atoms. Their relative mass to our solar system is in a specific mass ratio. What if we were to look at a galaxy using particles of this very same mass ratio to it that our atoms have to the solar system? We would no longer see a galaxy then. We would instead see a solar system. Inversely, the systems that we call atoms have a specific mass ratio with galaxies. If we looked at our solar system using particles of the very same mass ratio to it that our atoms have to our galaxy, then we would no longer see it as a solar system, but instead we would see a galaxy. And at the center of that galaxy would be what we observe as a black hole, though it is indeed the sun. As soon as we establish a pattern of sameness, we can extend it out to infinity in both directions. In so doing, we can achieve greater understanding of all systems by drawing the parallels that exist between each. This is because in all instances, we are looking at the same system mechanically, but only from different angles. In this way, we can see how the universe has infinite planes of existence underneath our feet, above our heads, around us, and within us, all of which function as one. We can use this same process of looking at similarities to unify rather than looking at differences to separate when it comes to ourselves. If we look for differences and use them as reason to separate ourselves from one another, we will create a highly complex system of explanation for all the intricacies of our separation. If we look for the similarities, then we will see that we are all the same, and we can thereby understand ourselves to be one.